this tutorial, we are going to discuss factoring, and more specifically, we're going to look at a process called split the middle. So if you notice here, I have two different problems. They are both, or two different polynomials, both with four terms, and they can be simplified. 8x squared plus 2x plus 12x plus 3, I can see I could combine like terms, and this would actually be 8x squared plus 14x plus 3. Same thing over here, 6x squared plus 9x plus 2x plus 3 is 6x squared plus 11x plus 3. So if I gave you these problems right now, I have not taught you how to factor a trinomial except for looking for a GCF. But if you go back to the original problem before it was simplified and it has four terms, we are familiar with grouping. So if I wanted to factor this by grouping, since there's not a GCF, I could start with the 8x squared plus 2x. The GCF there is 2x, which would leave us with 4x plus 1. And then the GCF of the second group, 12x plus 3, is a positive 3, which would also leave 4x plus 1 in the parentheses, which means in factored form, it would be 4x plus 1 times 2x plus 3. This factored form is the factored form of this trinomial as well. But again, we didn't know how to factor this trinomial. Only when it was not simplified and that middle term was split into two terms, making it have four terms in total, were we able to group and get our factored form. Same thing over here. I don't know how to factor this, but I could factor out of this first group a 3x to have 2x plus 3, and out of the second group a positive 1 to have 2x plus 3. So the factored form has a factor of 2x plus 3 and a factor of 3x plus 1. So what this is telling us is that we just factored this trinomial into a binomial times a binomial. But again, I wouldn't have been able to do it from this form. I was only able to do it from the form that had four terms. So is there a way to factor a quadratic trinomial by grouping? The answer is yes. We just have to do a little bit of manipulation. So what we have to do is split the middle term, meaning in this case, split the 11x to be two terms, positive 9x plus 2x. Split the middle term into two terms so that there are four total terms. Because we know if it has four terms, then we can use grouping. So let's take a look at how we would actually go through and do this. So I have the polynomial 2a squared plus 15a plus 18. The first thing you always want to do, step one, is always to check if there's a GCF. 2a squared plus 15a plus 18, the only factor that all three terms have in common is 1, so we're not going to be able to do anything there. Step two, multiply the leading coefficient with the constant. So the leading coefficient is always going to be the number being multiplied by the variable with the highest degree. So in this case, 2 is the leading coefficient. The constant is the number that doesn't have a variable with it, so positive 18. So if we were to multiply 2 times 18, we're going to get 36. So that's step 2. Step 3 is where we're going to use the X game, which is what we were talking about in class, about numbers that multiply together to be something but add together to be something else. So we want to find two numbers that multiply to be that product that we got from multiplying the leading coefficient and the constant. So in this case, 36. So they have to multiply to be 36, but we want them to add to be the middle term's coefficient, which in this problem is 15. So if we're using the X game, we would set it up like this. Two numbers that multiply to be 36, but add to be 15. So you might be able to come up with it by thinking in your head, well, 1 times 36 or 2 times 18 or something like that. Or if it's helpful, you're always welcome to make a t-table with all the factors of 36. So 1 and 36, 2 times 18, you could do 3 times 12, 4 times 9, and 6 times 6. So we need a pair of factors that multiply to be 36. So here are all of our pairs, but they have to add to be 15. That looks like we would be using positive 3 and positive 12. So this tells us then how we're going to actually split that middle term. 15a Could be split in a variety of ways, right? 1a and 14a, 2a and 13a, 3a and 12a, 4a and 11a. But there's only one combination that's actually going to work to be able to factor by grouping. And we just found that combination. We want to use the 3 and the 12. So we're going to split, we're going to exchange the middle term 15a with the two terms that we just found. We're going to split that middle term. So we're going to rewrite this as 2a squared, and instead of plus 15a, we're going to say plus 3a and plus 12a, plus because they're both positive. So plus 3a plus 12a, and then write down the end of it, so plus 18. So I haven't changed the value of the expression, I've just kind of unsimplified it, right? I've gone the other way. If I were to combine these back together, I'd get back to this original problem. But now this has four terms, so we've split the middle, that was step 4. Step 5 now is to go ahead and factor by grouping. So we do what we've been doing. Out of the group 2a squared plus 3a, the GCF is a, and we're left with 2a plus 3. 12a plus 18 has a GCF of 6, and that's going to be 2a plus 3 in the parentheses there. So that means it's going to be 2a plus 3 times a plus 6. It's always a good idea to check our work, but in other words, or in this problem, this is what we're thinking the answer is going to be, a binomial times a binomial. But to check our work, we would FOIL this out. 2a times a is 2a squared. 2a times 6 is plus 12a. 3 times a, and 3 times 6 is 18. If we combine like terms, 2a squared plus 15a plus 18, which is what we started with, it checks out. So I'll do a couple more examples, and then hopefully you'll feel pretty confident in this. 5z squared plus 12z plus 4. Again, the first step is to look for a GCF. So in this case, I don't see a GCF, so we're going to go on to step number 2. Step number 2 was to multiply your leading coefficient times your constant. So 5 times 4 is positive 20. We want numbers that multiply to be 20, but add to be our middle term, which is a positive 12. Two numbers that multiply to be 20, but add to be 12. You might be able to think of it in your head. You might need to draw a little table of factors of 20, like 1 and 20, or 2 and 10, or 4 and 5. We're looking for the pair that adds to 12, which hopefully you can see is 2, positive 2, and positive 10. So this is how we're going to split that middle term to be two more terms. So we're going to rewrite this as 5z squared, but instead of using 12z, we're going to say 2z and 10z, and then plus 4. I should note here that if you flip-flop where the 2z and the 10z are, maybe you put the plus 10z first, it's still going to work out. It's still going to be okay. So you can do it in whatever order you want there. So now we have 4 terms, which means we can factor by grouping. 5z squared plus 2z has a GCF of z. If I factor z out of those two terms, we're left with 5z plus 2. The GCF of 10z and 4 is a positive 2. If I factor that out, then in the parentheses is 5z plus 2 again. That's good. We want those to match. That means that one of our factors is 5z plus 2, and the other factor is z plus 2. So this would be our final answer. And again, I would want you to check that. But for the sake of this video, I'm going to speed this along and jump to another problem. So I'm actually going to jump to a problem like this. So 10m squared minus 22m plus 12. In this case, we do have a GCF. So the GCF of 10 and 22 and 12, I know is going to be 2. So I'm going to factor out a 2, leaving us with 5m squared minus 11m plus 6. Now, that 2 can't go away, but for right now, I'm going to kind of ignore it because now I want to split the middle with this trinomial. So the leading coefficient now is 5, and the constant is 6. So 5 times 6 is 30. I need factors of positive 30 that are going to add to be this middle term, negative 11. For two numbers to multiply to be positive but add to be negative, they're both going to have to end up being negative. So if you need to, again, you could list out the factors of 30. They're both going to have to be negative. So negative 1 and negative 30, negative 2 and negative 15, -3 with -10. -4 is not a factor, so we have -5 and -6. It looks like -5 and -6 would add to be -11, so that's what we want to use, -5 and -6. So in the next step, I'm going to keep carrying that 2, but I'm going to be making this trinomial into a 4-termed polynomial by splitting the -11m into -5m and -6m. So 5m squared minus 5m minus 6m plus 6. Out of the first group, 5m squared minus 5m, we could factor out a 5m, and we'd be left with m minus 1. The GCF of -6m plus 6 is 6 or -6. Remember, we want the parentheses here to match m minus 1. So if we're going to have that, that means we factor out a -6. And still on the outside, we still have this 2. So if it's helpful to put parentheses or brackets there, you can do that. Which means that this factors to be, one quantity is m minus 1, another factor is going to be 5m minus 6, and then you can't forget about your 2 in the end. So in this case, you have a monomial times a binomial times a binomial for your final factored form.